Okay, hello and welcome to my presentation for the final year dissertation. You can see my project was to assess different AI technologies for a simple board game. And you can see the board game here is it's called Cheskers, and I'll be going over that during the presentation. Supervisor for this project was Hans Wolfgang Little, and I am Lee Donovan. So Cheskers is a two-player board game. It was invented in 1948 by Solomon Golem. It takes elements from both chess and checkers. And so the goal of the game is to checkmate your opponent, just like in chess. You can see how the pieces move at the bottom here. You can see pawns move like checkers pieces, and the kings are supposed to move like promoted checkers pieces. And the knight just moves like a normal knight pretty much, and the bishop moves exactly like a normal bishop. So the aim of the project was to first develop this game and then develop artificial agents to play the game using two different technologies, namely Minimax and neural networks, and then finally compare them and do a systems evaluation. So I ended up with 10 agents in the end. You can pick which one is black and which one is white during each game. You can see them listed here. The human is the first one, that's just lets you play against the agents. Random just moves the pieces randomly. And then there's a lot with MM, those are the Minimax ones, and they search to different depths in the Minimax tree and use different evaluation functions just to try to get different results and see which is stronger. And then the NN ones down at the bottom, those use neural nets, and there's only two of them. The first one was just my initial one, and then the second one was an attempt to improve on that. Okay, and then I'll show you the demonstration here. So let's go out of here into Eclipse. Just run it here. So you can see it tells you the options, 2 to 9 are different AIs, MM Simple 2 being the strongest, NN1 being the weakest, and I'll go over my results later. But for now, let's just set up a game where I'll be the human player, I'll be the black player, and I'll play against MM Simple 2, because that's the best one. So it's just loading the GUI right now for the human player. You can see it's loaded here, and just for example, move that. And then MM2 is figuring out what to do. It's moved his pawn. Just for example, this would be a bad move, but if I moved my pawn here, then his pawn would capture, and get down here. So it would be able to promote to something. So if I do that move, you see he's captured both my pawns and promoted. So that's a bad move for me. Stop playing this for now. And just to show, if you don't if you don't want a human player, let's just have random versus random. You see it just does it all in the terminal here, so that's much quicker. You can see it prints out the board, prints out what move it took, and and then says the next turn, what they picked, blah blah blah. You can see after running these games as well, if we just refresh the project here, there should be a file called moves.txt, and this is generated every time any agent plays anything, even humans, random, neural net. So this is a unique representation of all the boards here. They're called bit boards. It's a 512-bit long unique representation of every board. And then you can see here, with that board, it chose to move from square 40 to square 33, and it didn't promote to anything. So I've also included a runnable executable file in the GitHub repo. So you can see the cheskers.jar there. So if I run that, see it says the same thing basically. So if I just let's do a human versus a random agent game. You can see here it hasn't it doesn't load the images correctly in the final executable. So I've just used the standard letter notations, and uppercase means it's your pieces, lowercase means it's the other player's pieces. But apart from that, it works in the executable. And I think just one more, just to show that we have the neural network pieces. Let's do a neural net versus the random agent. You can see it's loading in all the stuff it needs for the neural net, and then playing all the games. So back to the presentation, what were my final results? If you see the matrix right at the top, that is the main result from this project. You can see it shows the percentages of wins for each agent, 1 meaning it won every game, and a 0 meaning it didn't win any of them. And this was over 1,000 different games, just picking random agents to play against each other. So just for example, you see here, that means that MM positional 2 beat random 95% of the time. So if you take these numbers and average them, that's what you get these numbers down here, that tells you on average how likely it is that that agent will beat the other agents. So you see the best agent, MM Simple 2, will win 71% of the time, and the worst one, NN1, only win 4% of the time. And then finally down here, you can see how long it took for them to pick the moves, and you see it increases dramatically with the depth that the Minimax search to. Yeah, and final thoughts, just something that I forgot to mention in the final report was opening and endgame libraries. A lot of different chess and checkers AIs use those. I think I mentioned them in the literature review part, but not in the like how I could improve this work section, which I think was section 6. So yeah, opening and endgame libraries, want to include them. And then I want to fully implement the King's movement because, again, in the report I go more in depth on this. That wasn't fully working. Then I want to improve the GUI, make it much better for humans to actually play against it, and then finally work on improving the agents, especially the neural network agents, because, as you can see in the results, they were actually worse than random, because random wins 90% of the time. They only win about 4 or 5% of the time. So definitely want to improve those. Thanks for watching. That's the end of my presentation. And if you want to see the code, there is a link to the repo here. Cheers. Thanks for watching.